You know, most tech products, they have a pretty short shelf life. They burn incredibly bright for a little while, and then they just kind of fade away. But what if I told you there's a piece of software that's been a quiet, absolute giant for over 4 decades? We're talking about IBM's DB2.
All right, so let's set the scene. The year is 1983. Now, just to put that into perspective, this is the year the first commercial cell phone was introduced. You know, the big brick-sized ones. The internet was still this tiny project that only a few academics knew about. And yet, a technology born right then and there is still a critical part of our world today. So that's the big question, isn't it? How on earth does a database from the dawn of the PC age stay not just relevant, but absolutely essential in our crazy cloud-native, AI-driven world? Well, that's the journey we're about to take.
To really get why it's lasted so long, we've got to go right back to the beginning, to its revolutionary origins. This wasn't just some new product hitting the shelves. It was the launch of a whole new way of thinking about data.
You see, the story of DB2 doesn't actually start in '83. The seeds were planted way back in the '70s with this research project called System R. And this wasn't just any project. It's literally where the structured query language, SQL itself, was born. So long before DB2 ever hit the market, its DNA was already forged in some seriously groundbreaking computer science.
So, DB2 helped make this, the relational model, the absolute gold standard for business. I mean, think of it like this. It was like going from a bunch of messy, overflowing filing cabinets to a perfectly organized, searchable library. And running on those powerhouse IBM mainframes of the day, DB2 became the undisputed king of structured data.
But here's the thing about tech. You can't stand still. If you want to survive, you have to adapt. DB2 had to leave the safety of its mainframe home and venture out into some brand new digital territory.
Its first big move was a leap into the world of Unix, and this was huge. It proved that DB2 wasn't just a one-trick pony from mainframes. No, it was a flexible, powerful database that could run on the distributed systems that were starting to take over the corporate world.
Okay, so after Unix, where do you go next? You embrace the revolution, right? And that meant conquering Linux. This move opened DB2 up to a massive new world of developers and companies, locking in its place in the modern data center. And finally, to complete the trifecta, it established a major presence on Windows servers. So, by this point, DB2 was running on pretty much every major enterprise platform out there. It had successfully broken free of its mainframe-only identity.
And this incredible versatility meant DB2 wasn't just for one type of job. It could handle all those split-second, day-to-day transactions at a bank, that's your online transaction processing, or OLTP, but it could also act as a massive data warehouse, storing and analyzing decades of sales info for a retail giant. It could even be embedded deep inside specialized apps, a true jack-of-all-trades.
But, of course, the world didn't stop changing. The rise of big data meant that just storing information wasn't good enough anymore. Businesses needed to ask really complex questions, and they needed answers, like right now. DB2 had to reinvent itself all over again.
The answer was a total game changer called Blue Acceleration. Okay, imagine you're in a massive library, and you need to find every single mention of one specific word across thousands of books. If the books are just in giant piles, good luck. It'd take you forever. Blue is like having this perfect, magical index that instantly points you to exactly what you need because it organizes data in a fundamentally smarter way. So how does this magic actually work? Well, it's pretty clever. First, instead of looking at data one row at a time, like a spreadsheet, it organizes it in columns. This makes analytics queries, which usually only care about a few columns anyway, incredibly fast. Second, it uses some really smart compression to squeeze a ton of data into the computer's super fast memory. And third, by working in memory, it gets to skip the slowest part of any computer, waiting to read from a spinning disk.
And believe me, the innovation did not stop there. IBM added things like Pure Scale, which is basically bulletproof availability, for places like banks and airlines that absolutely cannot go down, ever. It learned to speak the language of modern apps by supporting formats like JSON and XML. And more recently, it's even started using AI to tune itself automatically for the best performance.
Okay, so all this technology is impressive, but what does it actually do? Well, it turns out DB2 is kind of the invisible engine running behind the scenes of our everyday lives.
Just look at this breakdown. A massive portion of the world's banking and financial transactions run on DB2. We're talking ATM withdrawals, credit card swipes. Yeah, DB2 probably handled it. It's managing critical government records, powering the supply chains that get packages to your door, and handling sensitive healthcare data. You've probably used DB2 multiple times today and had no idea.
So why do all these huge, critical industries bet their businesses on it? Well, it really boils down to three things. 1, it's rock-solid reliable. It just works. 2, it can scale to handle just an unbelievable amount of data. And 3, and this is a big one, it offers backward compatibility, so companies can upgrade without having to rewrite applications they've been depending on for decades.
And that brings us right up to today, to its latest and maybe its most impressive transformation yet. It's not just about adapting for new servers anymore. It's about adapting for a whole new way of doing things, the cloud.
Today, you don't need a giant mainframe in your basement to use DB2. You can get it as a fully managed service right in the cloud. There are specialized versions just for analytics and AI. It's built for hybrid cloud, which means companies can run it both in their own data centers and in the public cloud at the same time. And it's all containerized, so it speaks the language of modern developers, working with tools like Kubernetes.
You know, this slide really just says it all, doesn't it? What started as a mainframe-centric beast for neat, structured data is now this flexible, hybrid cloud platform that handles all kinds of data and is supercharged with analytics and AI. It's just a remarkable story of constant evolution. So that leaves us with one final thought. After surviving and, frankly, thriving through all these different eras of technology, from mainframes to client-server to the cloud, what's next? In a world that's moving towards serverless computing and decentralized data, what's the next move for technology's ultimate survivor?